Rise Robotics has invented a new kind of linear actuator that doesn't have the challenges of hydraulics, which are primarily leaking, durability and speed, and then doesn't have the challenges of screw type actuators, which are also speed, shock handling, and stroke length. And the way I describe this to people, to laymen, is think about how the human body works. Inside the human body, we really aren't pushing anything. Even if we want to push something, we're using muscles on the inside to pull, and then our joints create the pushing motion. And because we're using fibers and we're pulling internally, that gives us a few advantages. The fibers last a very long time because the force is very focused. Muscles get blood and nourishment and so on, but they generally last a lifetime, which is a very long time. They're very efficient. Imagine how little food we need to eat to do the kind of work that we have to do. And they're very fast.
Welcome to Venture Step Podcast, where we discuss entrepreneurship, industry trends, and the occasional book review. I'm your host, Dalton Anderson. In this episode, we have Hiten Sonpal. He is the CEO of Rise Robotics. For 60 years, heavy industries relied on hydraulic actuators. But Rise Robotics took a look at the human anatomy instead. Mimicking muscle fibers and an advanced belt system, they've created a clean tech so powerful that it's landed them in the Guinness World Record book, and it's caught the attention of the U.S. Air Force. Today, we're breaking down how this fluid-free future works and what it means for the next generation of technology. Can't wait to dive in on this one. Hey, Hiten, welcome to the show.
Thank you for having me on, Dalton.
Yeah, we're going to get right into it. So we're going to be discussing some new technology when it comes to the actuator space. It is a different take, and it's a belt and pulley system. And Hiten, I'll leave the technicals to you. And then we're going to talk about how you found your sweet spot for your target customer base, at least in the coming stages of the company at the moment. And then talking about some real world applications, and that could be the Guinness World Record Super Jammer for the Air Force, or it can be talking about just like the path of autonomy for heavy machinery. And then just the next part is crowdfunding and the cool initiatives that you had in there.
Sounds good.
Okay, so the first part is, the what and the why, like what's going on. Like there's fluid-based hydraulics, then there is this like screw-based systems, and what are their limitations, and how does Rise Robotics have a different take?
Yeah, sure. So hydraulics is very common in heavy machinery these days, and it has been prevalent for, call it 5 to 6 decades. And it's one way to create linear motion. So if you're pushing, pulling, lifting, or lowering, hydraulics is the way to do it if you have anything that requires a substantial amount of force. And more recently, companies have started to use screw type actuators, but they can't provide a ton of force. They can't go very fast, and then they end up being very heavy and expensive as you increase their stroke length. And so what Rise Robotics has invented a new kind of linear actuator that doesn't have the challenges of hydraulics, which are primarily leaking, durability and speed, and then doesn't have the challenges of screw type actuators, which are also speed, shock handling, and stroke length. And the way I describe this to people, to laymen, is think about how the human body works. Inside the human body, we really aren't pushing anything. Even if we want to push something, we're using muscles on the inside to pull, and then our joints create the pushing motion. And because we're using fibers and we're pulling internally, that gives us a few advantages. The fibers last a very long time because the force is very focused. Yes, muscles get blood and nourishment and so on, but they generally last a lifetime, which is a very long time. They're very efficient. You imagine how little food we need to eat to do the kind of work that we have to do. And they're very fast. So we can like throw a ball and so on. And robots have just gotten there, the last couple of years, being able to do stuff like that accurately and at speed. So that's how nature has done things. Now, if I told you that I'm going to try and improve this system by taking away muscles and replacing them with bladders, and if I wanted to move my arm, my heart's going to pump blood into the bladder, the bicep bladder, and I'm going to open my arm that way. And then my heart's going to pump blood into my tricep bladder to close my arm. You can imagine how slowly that would move compared to muscle fibers that are pulling. And you can also imagine how inefficient that would be with the heart moving all this blood back and forth. And then you can imagine how easily it would fail because of all the pressure that's being applied along your internal organs, right? The bladders. And that's essentially what happens in hydraulics. They're inefficient because you're moving all this fluid around just to get linear motion. And you really want to find ways to not move the fluid. And you can't move it very fast because you can only move so much fluid. It takes a lot of energy to move the fluid. And you're also moving it through pipes and hoses, which have small openings. And the pressure ultimately makes these systems unreliable. They end up leaking. They leak because the pressure shows up at every interface. That includes seals, but it also includes fixed interfaces, which over time give out because of all the pressure. And so that's why, inspired by nature, Rise has invented this new kind of actuator, which we call Beltrolic, where instead of muscles, we replaced those fibers and emulated them using belts and pulleys. And the belts we use are relatively new. They've been out only 2 decades. They were first introduced by the elevator industry, which is a human-safe application, right? So they're introduced by the elevator industry because they wanted to do something better than the steel cables that they were using. The steel cables eventually rust, they fray, there's steel on steel contact. You can't run them very fast because they have inertia and they tend to whip around the spool. The cables themselves have a ton of mass. And so they came out with this new design, these belts that are made out of polyurethane and have steel rope on the inside. And the polyurethane protects the steel from the environment, and it also protects the steel from rubbing on itself. And this has allowed the maintenance on elevators to be completely eliminated because the belts will last the life of the building. So we started with that core technology, and we figured out how to package it into a cylinder, and we created a linear actuator that runs 3 times as fast as hydraulics, is 3 times as efficient, and we expect it to be 3 times as durable.
Those are some great points. The thing that I think about as well is when you think about all the pressure that you have to put on these cylinders, when you talk about hydraulics, you also have when you're not doing anything and you're trying to keep it at a level, or it's not the right way to phrase it, but when you're trying to keep it at, say, I don't know, 2 degrees above whatever the zero is, then you constantly have the pull against the pressure valves, the wear and tear of the device. It doesn't seem as if it is efficient if you have to move the pressure up and down. And there should be, I would think, some heat loss when you're thinking about like a hydraulic system, when you're moving the pressure back and forth, when you have to change the pressure devices. And then one thing that I would like you to dive in a little bit about is the screw actuators. You were talking about how they don't go fast and you can't make them go fast. And one of the reasons of that is, I think, what it's a term called screw whip. And
Yes.
wondering if you could dive in a little bit about that. I think people really understand the inefficiencies of hydraulics, but what about the precision and then the lack of speed of screw based?
Yeah, some of the advantages that screw-based actuators bring compared to hydraulics is precision, as you mentioned, and that's because they're mechanical systems, right? And they don't have fluid on the inside, and so you can be very precise about how you control them. The challenge is, as you mentioned, it's around screw whip. Once you start running a screw really fast, especially as the stroke lengths get longer, what happens is that the mass of the screw starts to cause it to cycle, almost like a skipping rope, like a jump rope. And so the system becomes unstable and has tons and tons of vibrations. And that makes it very hard to run these actuators at any kind of reasonable speed. And then the last part is that screw type actuators have metal on metal contact in the shock path. And so if you were to take a screw type actuator and you hit it with a lot of force or were to experience a shock event, there's deformation that happens in the metal on metal contact, and eventually the screws get ruined. So you have to really upsize them to deal with any kind of shock, which hydraulic systems natively deal with shock, not because they're designed to, but just inherently because of the physics. The fluid is compressible to some extent. The hoses can expand. There typically is a reservoir that can absorb some extra fluid. So that capability is not available in screw type actuators. Now you could add springs to add that capability, but then you lose precision, right? So those are the challenges. And then I'll say one other thing is as you increase the length of a screw type actuator, what happens is that you're increasing the precision metal. And so you're increasing the cost of the system. And not only are you increasing the cost of the system, but you're also increasing the weight of the system. So at some point, they're untenable because the actuator is taking away from the lifting capacity of the system. So those are the trade-offs when it comes to screw type actuator.
It seems there's this threshold between the two, whereas like hydraulics, it has longevity, but it has an inefficiency of moving up and down or making slight changes, but can do so, but has prone to leak, maintenance, and issues and pollution. And then screw actuators have great precision, but I would say not as long of a longevity as a hydraulic base, but then also doesn't have the flexibility of moving up and down as fast and can't be as big because you've got to account for something like shock absorption or the longevity of the screws within, I guess, the threads and the pressure on the actuator. Is
That's
that
right.
is fair? Then Rise Robotics built this new technology that takes like the precision of the screw base actuator and then the longevity of the hydraulics base and really got inspiration from the initial iterations of elevators and then packaged that up into an actuator form.
That's right.
Okay, so it seems like it's a fundamentally new technology, not necessarily brand new, like it's been around, as you mentioned, with the elevators, but it's a new way of thinking about moving heavy items or thinking about machinery or robotics or heavy machinery. So that is a new infrastructure, right? And so this is brand new in the sense that the technology has efficiencies all around. Like it takes the best of both worlds between these two industry standard types of approaches. And you have this other upcoming piece, which I think is coming faster than people expect, but like mass use of robots and humanoid robots and automation of heavy machinery and construction. I think my dad a couple of years ago was stating that he runs job sites for big commercial buildings and they had a robot that comes in and does all the blueprint scanning for everybody. And they've just got what would have taken weeks, like months for bigger buildings, because each contractor needs to go out there and do their blueprints and do their stuff. And if somebody messes up, then you've got to go back to step one and redo everything. They've got a robot and they just have a 3D scan of the building and where stuff's supposed to go. Robot scans everything and carries on. They just decreased it from a whole bunch of teams on site to a robot, and then somebody taking that person floor to like not a person, the robot floor to floor. But what I'm really getting at is like figure one robotics just had a 5-day human versus robot competition of something simple, but it was classifying packages and flipping the package over and getting it to the face down where the barcode scanner is face down. And they did that for 5 days straight. They switched out interns, but then the robots worked 80-hour shifts. So we're getting to a place where this thing is becoming more mainstream. So what I'm getting at is AI and these different enablements and us trying to be a multi-planetary race. We've got to change the platform to enable these kind of things. And I think this is probably one of the first steps, but we've got to get everybody to make sure that they understand the concept of like why this technology is huge and discussing that on a micro level.
Yeah, you're absolutely correct that automation is coming in a big way, but that's been how humans have been doing things since time immemorial. Immemorial, we're looking for tools to amplify us, and that amplification just continues. And when I think about the next wave of autonomy or AI and so on and so forth, I tend to think of it more as human amplification than I think of it as human replacement. So you mentioned being able to scan job sites and being able to do it accurately. Well, now you've got more people who can build faster and you can grow your business, right? And you can do things at less cost, which means that overall you can increase the wealth that everyone experiences because being able to bring down the price of goods and services is ultimately what makes us all wealthy.
Correct. Yeah. No, that's how I always frame it is it's not necessarily people are going away. Like we're always going to be here. It's just that you get to work on different things. Like instead of working a brutal job where you are flipping a package, you're maybe monitoring the robots and maintaining the robots. Like somebody's got to maintain these robots and maintain these types of actuators that we're talking about. And I was looking at the comments. This is a quick sidebar, but I was looking at the comments of somebody who actually worked that job for a couple of years about scanning the packages and the competition. And they were talking about the strain that that had on their body because it's the same movement over and over and over again. They said that it really messed up their shoulders and their back and their posture's all jacked up. So there's just some things that are super repetitive that probably are not as optimal to be doing, and you can do something else that you find more value in, or the society will value more.
Well, absolutely. And, it, it is, this is obviously a bigger topic, but I think it's incumbent on us as a society to find those better jobs, to identify those and make sure that those are available to folks, right? I think um, just solving one half of the problem, which is, hey, this is a bad job, so let's take it away. Well, we have to give you some other option. And to your point, those options end up being in engineering, where you're designing robots and automation systems. They end up being in in sort of more skilled operation and supervision of these systems, and then they end up being in the service and maintenance of these systems. And those are all higher skill jobs than sorting bags, and so they pay more, right? And but there is some, oftentimes there's some disruption before people start to see, okay, here are what the new opportunities that are being created by this technological change.
Yeah, time and time again, electricity, internet, phones, cell phones, personal computers. I mean, it goes on and on. I think every time that there's some initial blips of freaking out and disruption, and then recalibration. But no, that's life. Change happen with or without you. Speaking of change, so this technology, it is impactful, right? Where there's more precision, there's less maintenance, there's less waste, it's more efficient. So when you're identifying your ideal customer base, like how do you think about that? Because I think about it as you've got to shift and provide a different level of expertise to this group, and also got to be interested to up in their current process and upskill their workers to maintain these new devices.
And that's a great question. So startups have this challenge. Typically, like if you work with a customer that's too small, oftentimes, all the effort you put in doesn't really translate into meaningful revenues, and they might not have money to help you get to the finish line. And then on the other end, you've got larger customers that you can work with that would take years to make a decision. If they decide to change their mind after you've been working with them for 2 years, then all of a sudden, all that time and money is wasted. So most startups pick companies that are mid-market. They have the funds to be able to engage. They move quickly. They can make decisions quickly. The number of stakeholders is small, and you can really make things happen. And that's why, most VCs that are investing in startups are always asking, okay, who are you targeting? And they want to hear that it's a mid-market customer. The second piece of it is that for us, being a hard tech company, development is expensive, and engineering is expensive because you have to design it, you've got to make it, you got to build it, you have to actually test it. You can do some of it in sim and some of it in analysis, but you still actually have to build a physical thing and find your unknown unknowns that you couldn't find in sim or analysis. And then that takes time. And initially, when I joined Rise Robotics, our goal was to get into construction. Construction is a huge market. I think over $100 billion, right? And what I decided to do instead is start to find customers that could meet us where we are, where we didn't have to do a ton of engineering. And the reason why construction requires a lot of engineering is because the equipment gets abused on a regular basis, right? Operators are just trying to get things done, and they end up using the machine in ways that it's not meant to be used. So the test cases and the corner cases aren't simply, can you do this job? It's, can you handle this equipment being used in ways that it wasn't intended to be used? With oil and gas, so what we did was we started to look at other sectors, and the sector we found that appealed to us most was oil and gas. And actually, the noise you hear in the background, I don't know if you can hear it, but is one of our tests running on a natural gas pump, because we partnered with a Texas-based mid-market natural gas pump company, and they have these natural gas pumps that take the gases coming out at oil wells and they pressurize them into a sellable pressure. And they use hydraulic systems today. And their challenge is that they have to service these systems every 3 months. And we expect to extend that service length to that service life to 9 months. So their service team, which they're having trouble hiring people to do this job, their service team will be able to bring them 3 times as much service revenue using our equipment, because the same number of people, but they'll service 3 times as many wells as us. We're a clean tech company, so it is strange that we are working in oil and gas, but oil and gas production is actually one of the dirtiest sectors. And so we're thrilled about being in that space, eliminating the need for hydraulic oil and to get rid of hydraulic oil that's been fouled, improving the efficiency of that whole operation so that less energy is wasted in the creation of energy.
That's a great point. I was wondering, just out of curiosity, how much hydraulic oil do they have to cycle through? Like, how long does the oil last for? And oil is petroleum based, correct? Like, I don't know if it's if it's processed or a special type of oil. I'm not sure the components of the oil as well, but just out of curiosity, so you're talking about an oil well, like how much hydraulic oil is needed to pump the well and have it functioning properly or work? And I guess also the other part is like how much energy, what's the energy difference in the spend from using the new technology, this like the pulley system versus a hydraulic pump, or not hydraulic pump, but like a hydraulic actuator?
That's a great question. Now, the amount of hydraulic oil used depends on the size of the pump, which drives the size of the cylinder. So it's different depending on pump. So, but what I can share with you is that the hydraulic oil gets fouled every 3 months, and that's primarily the failure mode of these systems, and that's what has to get replaced every 3 months. In terms of efficiency, when we compare ourselves directly to a hydraulic system at the cylinder level, we are 3 times as energy efficient. So our efficiency is 75%, and the hydraulic efficiency typically is around 25 to 30%. So we're roughly 3 times as efficient. And because of our high efficiency number, we're also regenerative. So if you backdrive our actuator, we actually end up generating energy. So if we're used in a, call it not necessarily a natural gas pump application, but if we're used in a oil pumping oil pumping application where there's gravity on the other side, or a forklift application where there's gravity on the other side, anytime we lower the piston, we end up recharging the battery or putting energy back into the grid.
That's very cool. I'm just processing that for a second. So if you have, the way that I could think about it for me is that you can use the friction to, this is not how it probably works, but like I'm thinking about as like regenerative braking. Like I don't necessarily know. Could you dive into that a little bit to make sure everybody comprehends?
Yeah, it's exactly like regenerative braking. In regenerative braking, you're decelerating the system, and that change in acceleration requires a force, and that force shows up in the electricity that you're pulling out of the motor. So if you're with electric motors, they have this interesting property that if you put electricity into them, the axle will turn, and if you, the rotor will turn. But if you, on the flip side, if you turn the rotor using an external force, then it's going to generate electricity and put it out. And so that's what happens in an electric car is when you hit the brake, the when you let go of the brake, the amount of electricity that's being generated by the motor at that point, because it turns into a generator, matches the voltage that you're putting the energy into. And so that's why you have the car coasting. And then when you hit the brake, what the electronics are doing is taking the voltage that comes out of the motor and actually putting it into the battery. And that work that's happening is the thing that starts to slow down the car. And that's what we're doing. When we lower something, we're actually working against the acceleration force of gravity. So working against an acceleration force is the same as decelerating, and it creates a force. And because it's a motor, it ends up creating a voltages. It's called EMF. So it's electromagnetic force that comes out of the motor.
Got it. That makes more sense. It made sense to me as regenerative braking, but then I was thinking, okay, well, if we're talking about gravity and how does gravity and the force of gravity translate into like turning the motor, which made less conceptual sense to me, but after you explain it that way, it makes more sense. On the topic of the oil and gas industry, so you've had the successful application and you're able to provide a meaningful top line benefit and bottom line benefit when you talk about environmental exposure, maintenance usage, and energy efficiency, like all around, like a great outcome for everybody involved. What are some other applications like the super jammer? That one's quite interesting.
Yeah, so the Super Jammer is a replacement, is a next generation device that replaces these things called jammers. That's I'd say, the casual name for munitions handling units that are used by airmen. So the existing munitions handling units are all hydraulic. They're six-axis systems. And when they initially roll off the production line, everything's fine. But they age relatively quickly. And after a while, the hydraulic systems start to leak. And in most of the units that are in the field, the hydraulics are leaky. And what happens when the cylinders leak is that the munition that's being loaded starts to sag. And it can sag in any one of six different axes based on which hydraulic cylinder is leaking. And so the folks that are trying to load the munitions onto these bombers have to constantly jiggle and jostle the hydraulic controls to keep the munitions at the right point while by the wing while someone's trying to pin the munitions onto the wing up a very long time. This is something that we should be able to do faster. In addition, because it's hydraulic based, it's inefficient. And so it requires a large engine to generate all the energy to lift these munitions. These munitions can weigh up to 7,000 pounds, and they have to be just positioned. The machine has to be positioned so that it's lifting these things effectively at a 7 foot extension. So there's a lot of force that has to get put on the end of the arm. And so the hydraulic systems end up requiring a lot of energy. They're throwing most of the energy away. Very little of it is being put into useful work. And so they end up requiring a massive diesel engine to operate these systems. And those diesel engines emit diesel smoke. Even while exercises are happening, our airmen are inhaling this smoke, just trying to get their efficacy up. And then the engines are noisy. So people are wearing ear protection and then yelling over the engine to try and coordinate activities. And this is a very inefficient way to do the work. And after they're done running the exercise, then someone has to come out with a Zamboni and suck up all the hydraulic oil that's been spilled. So you can imagine just the amount of waste in just a very essential operation to the Air Force. And so they came to us and said, can you build us one that doesn't have hydraulic fluid and doesn't have these maintenance problems? And oh, by the way, we also want a higher safety factor. Can you build that into the system? And we'd love for it to be hybrid so that we can turn off the gas engine, especially when we're inside a hangar. So these days, these machines, when they're operated in a hangar, you still get diesel smoke, right? And so they want to be able to shut that off. And then there's times when you want to do this operation quietly. And so what we enable is we built kind of electric versions of the arm. That's the first piece that we built. A few months ago, we won a contract extension to turn that into a vehicle that they're going to test and evaluate. But the arm we built for them is capable of lifting a Ford F-50 Lightning and manipulating it in six axes, right? That's about a 7,000-pound truck. And it's the first robotic arm that can lift that much weight. So we got into the Guinness World Record book for building the world's strongest robotic arm last year, which was a lot of fun.
A lot there. Want to start back at the top. So can you explain what a six-axis hydraulic system is?
Yeah. Well, a six-axis system, whether it's hydraulic or electric, involves manipulating something in six dimensions. And those dimensions are roll, pitch, and yaw. So that's in sort of the rotational directions. And then in the linear directions, it's, left, right, front, back, and up, down.
And then talking about just getting the munitions onto the plane and then attaching it, it seems like just such a headache. It sounds like a headache when you're thinking about the diesel engine, the yelling. It seems like a really stressful situation when it doesn't necessarily need to be, especially when you're inside with the fumes.
Yes, it does not need to be this way. Yeah. In fact, the slow turnaround time means that we need more planes than we would if you had something that could turn the planes around and keep them up in the air faster.
It's almost, sorry, I was going to say, it's almost like you're talking about they might need less planes. In this instance, you turn it back to the oil part where it's like you need less. You can actually have more revenue because you have to service it less. And in this instance, it's like you could get to the point where you're more efficient, where you feel comfortable like decreasing. Not saying that we would do that, but just you could decrease theoretically the amount of planes that you need because you can turn and burn on adding in the munitions that you needed.
That's right. If you increase the availability of the assets that you have, then you don't have to put as much money into new ones, and then you can redirect that money elsewhere. And so I think this can help reduce, it's not going to reduce the defense budget, but it can help redirect those money more effectively.
Were you there when the record was officialized, or were they I know there's somebody shows up, they're an official record keeper, and you do your thing, you do your song and dance, like you're at the talent show, and they record it, and then they're the ones who notarize the record. Like, how does that work? How's that process work?
It's a two-step process. The first step is that you have to send in all the materials. So, you start the process by working with them and they tell you, here's the evidence you need to generate for us. And then after they review the evidence, they come back and they send someone to give you the award. So for the evidence, they required an independent third party to come and test our weights to make sure that the weights were the weights that we thought they were when we were measuring the stuff. And then they put in place the right measurement elements into the arm so that they could see that we were lifting the full weight. And then they captured it in video. And then we had to have a local policeman that could verify that the people who were there were actually the people that we claimed were there. So they had multiple layers of checking, and then we submitted all of that evidence, and then they finally said, yes, you set the record. And then they sent someone down. And the line that they end with after giving us all of the compliments is, congratulations, you are now officially awesome, which is,
Really?
which is a fun line. We're all chuckling when we heard that.
Yeah, that's interesting. I didn't know I knew it was serious where you'd have to submit something and then like somebody shows up, but I didn't know it was like a 4-factor verification where you send it, they verify the evidence, then they feel it's credible, they send out a third party comes there, verifies the information, then there's a police officer that verifies that you're even there, and like the people are there. It's like that's crazy. So it's a lot of steps. It's a lot of steps to try to jump through to I guess BS the record system. Like they're not messing around there.
They are not messing around. And we wanted to go through the process anyway because we wanted to be able to prove to people that our Beltrolic technology is as strong as hydraulic technology, right? That red cylinder you see back there in the shop, that one is capable of pushing 50,000 pounds. And we can build them large enough to push 100,000 pounds.
In pounds. I mean, I don't think a lot of people know like what type of things would you be doing with 100,000 pounds? Like,
Yeah, huge forklifts at ports that are unloading container ships. There are telehandlers that can actually lift small boats out of the water in marinas and move them around. And then, of course, you start to think about mining equipment, bulldozers, dump trucks, and so on and so forth.
you triggered me. I love those big like mining like dump trucks. They're huge. Like the tires are like 40 feet tall or something crazy. Like it looks very sci-fi. Like what's going on with the sound in the background? Is that one of the tests that for the
Yeah, so our
natural pump?
test, yep, that's right. For the natural gas pump test, we're basically testing using a air pump to simulate the gas pressure coming in and the pressure we want. And so what you hear is a release of the air pressure from the pneumatic system, the pneumatic test system.
And what does that do just for the audience? Why are you doing that?
Yeah, so we're doing that to emulate the that we're actually getting the gas throughput that the customer would like us to deliver. And we want to know not just whether we can meet their criteria, but how much we exceed their criteria by, so they can have a conscious ROI decision. Because our customer builds these natural gas pumps and then they sell them. And so giving them the right statistics about how much more we can move with the Beltrolic technology or how much more gas we can pump is going to be important for them to sell the machine to their customers.
No, that is cool. So it's almost like if you want the premium product, this is how much better it is. Oh, by the way, it's more efficient. Oh, by the way, it actually you can pump more gas.
Yeah, we're definitely more expensive, right? So this is a return on investment case, and sometimes it's over the life cycle, as I mentioned in maintenance, but sometimes it's just, hey, you're going to just get more out of the equipment from the get-go.
Transitioning to getting more out, I think getting more out of the capital market. And so I know that went through like regulatory crowdfunding and had a series there. I would be curious talking about that in the scope and lens of people who are investing could be potential customers or like huge advocates and innovators. Because if you're deep in this tech, then it's probably more niche than you would think. Maybe you are thinking it's niche, but it's broad, but also niche at the same time. And I would think if you had people investing and it's crowdsourced investing and a very, very popular one at the numbers, and you can go more in detail with that. But just the perspective of having someone being your best customer and your best marketer are the people who are like the first adopters and investors, and to have that part of the driving of growth and acquisition of customers.
Yeah, the customer piece was a side effect. So what happened is that when I joined Rise 2 years ago, the previous CEO, one of the co-founders, mentioned to me that we had 1,500 followers on LinkedIn and on social media, and I said, "Wow, that's an interesting number for a company that's building B2B systems, right?" And he said, "Yes, there are some folks that are interested in our climate tech, and then there are some folks that come in and have seen the shop because they delivered something here, like the local FedEx guy, and they're all following us because they think this is cool, and many of them have asked us how they could get in on the upside of what we're doing, right?" And so that got me thinking and said, maybe we can do something here where we can allow these folks to invest. So I was advising a company that had done some crowdfunding and they had success. And so I said, why don't we try this? And we did some research and we found out that there was this rule passed, I think, by the Obama administration called regulation crowdfunding, where the SEC allows private companies to raise up to $5 million of capital through crowdfunding, and they have certain requirements that we have to meet. So there are certain auditing that we have to do, and then we have to use an intermediary platform, and that platform has to make sure that the investors are educated about the risks and so on and so forth. And so we did some research. We found a platform. We settled on WeFunder. They were the most popular platform when we selected them, and I think they still are. And we ran our campaign last year, and we were surprised at the outcome. Had $5.8 million of interest. We were the number one Reg CF campaign of last year. We have over now almost 3,000 investors in the company. The smallest check size is $250, which is what we take. But our average investment is $2,000, and we've had people that have written $100,000 checks, right? So it's just all over the place, and it's kind of exciting. And part of the reason why we think it's successful is, of course, there are people who care about the fact that we're working on climate tech and it's clean tech. But there are other folks that have used hydraulic equipment and have suffered with the maintenance issues and the leaks and the kind of the nasty smell and getting oil all over them and the remediation that has to be done to clean it up. And then there are folks who like the fact that we're doing things for the defense sector. So they, people that were in the military and have retired and feel like, hey, this is one way I can invest in this company because ultimately what they do is going to give back and improve the quality of lives of those who protect us. And then we've had some professionals who are investing in us because they figured out that it was a good deal. And I'm not the one saying it's a good deal. It's the third parties like King's Crowd that look at a lot of crowdfunded deals, looked at our deal and said that we were a good deal because we had essentially opened up our previous round, which we had priced for institutional investors. We just opened it up at the same valuation or very similar valuation to retail investors. And so, there's some companies in the crowdfunded space that try to sell very little of their company and make a lot of money, and usually they get rated very poorly and don't have very much success. And so we just offered what they thought was a good deal. And so there were all these professionals that were looking to get into companies early, because by the time a company IPOs, like for example SpaceX, I think it's like 1.5 trillion. There's no way. I don't think any investor in that company is going to make money. The process of going public is helping the earlier investors make money, right? So you want to get into the companies earlier, and that's what Reg CF allows us to do, or allows retail investors to do. So we have some professionals who've seen this as an opportunity. Yes, it has some risk, but see this as an opportunity to get in early. And we have a couple of folks that are older and they intend to leave the investment behind to their kids, right? And there's it's just interesting to see the kinds of folks that we've gotten. And these 3,000 people have offered to help in all kinds of ways. Introductions to other investors, introductions to potential customers, writing testimonials. It's just been fantastic having this many people in our corner.
If it's not clear enough, this is not financial advice, by the way. But the question I have, do you think that this opportunity gives you and the company a big edge when you think about just having that many different perspectives? I mean, some people might call it noise, but others might call it a different perspective and advocacy.
Yeah, so I take one-on-one calls with some of our larger investors. I've probably been on over 100 calls with investors, and sometimes I'm just asking them for feedback, right? If they've written a big check, I want to know why they wrote the check. What are they thinking about the business? Oftentimes they've been in a related business, so it's very useful to get their perspective. Like they're a small business owner that sold their business and retired, and so I want to hear why they liked our campaign, what resonated with them, where they see the applications, are there things that we're overlooking, and so on and so forth. And occasionally we get folks giving us very interesting advice. So one investor mentioned to us that aircraft carriers have these lifts that bring up the planes, and they're hydraulically powered, and they have a lot of failures. And so they said, hey, why don't you try to see if there's someone you know in the Navy to see if you can find ways to help improve those systems. And so we're working through that process, and we found a champion in the Navy, and then it takes a while to find the right person, the decision maker, and so on and so forth. But we're working through that process. So it's exciting that people give us ideas about industries we could be in.
Yeah, I think that the only thing that you really need is feedback and meaningful feedback and people that are interested in seeing you succeed. And to get that where it's mutually beneficial early can make a huge difference. If you're just working on something on your free time, you got some kind of passion project and randomly it's shown to someone and they're like, wow, like this person really gets it. I would love to help them out, like maybe set up some kind of deal that changes your whole trajectory. It's like almost like if you're new and you're getting some kind of mentorship from somebody that's a very experienced, it's not necessarily you don't know what you're doing. It's just like you just need somebody to chop down the bushes and see the next path.
Yeah, and it's super energizing, and we hope to be able to give energy back to our investors. So in our previous round, anyone that invested over a certain amount got a plaque from us that said, you helped us set the Guinness World Record, which was cool, right? We wanted to be able to thank the people that supported us make that happen. And that those funds have helped us land our first 3 customers, and we have a few more in the pipeline. I mean, we have a large pipeline. We're just very selective because we go through a customer qualification process, and it's all about making sure the customers can meet us where we are. But it's been fantastic. It's just this whole process of crowdfunding. It's paid huge dividends that I did not expect.
Taking a bet on people is one of those important things when you're trying to do something incredible. The essence of crowdfunding and the company, like how would you like folks to get involved if they are interested or if they want to get in contact with yourself or they have any questions or stuff like that or get in contact with the company?
Yeah, sure. If they're interested in seeing the investment terms and the deal, they just have to go to invest.riserobotics.com, and it's going to take them to our campaign page. And there are a couple of companies that have written investment memos that talk about the upside, but also the risks. So there are third-party assessments of the deal. And if they just want to get in touch with me because they have an idea that we should look into, or they're curious about our products and technology and want to use them in their products, they can just go to our website at riserobotics.com, and there's a contact form where they can fill out their information, and someone will be in touch within a few days.
Sweet. Well, I appreciate you on the show. It was very interesting, very intriguing topic. And I close out the show with wherever you are in this world, good afternoon, good evening, good morning. Thanks for listening in. Listen in next week.
Thank you, Dalton.